Well, hello, I'm Tim Osswald from the University of Wisconsin-Madison, where I co-direct the Polymer Engineering Center. What you see here may seem to you like a regular 3D printing machine. In fact, it's built on the platform of the Mini Lab, which is a machine from FuseForm. But this one these four actually differentiate themselves from the regular Mini Labs from FuseForm, in that they have a sensor that measures the force that is applied on the filament when we do 3D printing. Also, it has an encoder that will measure the speed of the filament. So this was built for us to validate a model that we have that has a melting, that predicts melting in a 3D printer in a fuse filament fabrication process. And it actually, which works quite well, and we were able to actually validate this model. Then we said, well, together with Juan Blanco from FuseForm, what if we acquire that data and do something with that data? And so, using neural networks, we captured the data, we performed a model to predict it using the data, and as soon as we would deviate from that data or from that model, the machine would then detect a change. It could be a change in the material properties of the filament, it could be a sudden drop in temperature, it could be that we're printing too fast, etc. And so these four machines are actually used in one of the labs in the Mechanical Engineering 310 course, which is manufacturing with polymer processing in the unit on 3D printing. And the students then get to use and learn how FFF processes work, but also they get to use advanced numerical analysis and machine learning and neural networks to be able to assess a process and to predict how a process is performing. So thank you, FuseForm, for actually helping us advance education of our students here at the University of Wisconsin-Madison.